can you solve this geometry challenge? Here's the question. Given this triangle, and take note this figure is not drawn to scale, let this angle be equal to alpha, this angle be equal to 3 times alpha. Let the length of this side be equal to 3, and this side be equal to 8. And the longer side, let's call this as x. Now, the question is, what is the value of this segment, x? Pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer to this question, the length of this segment x simply equal to 10 units. And that is the answer to this question. And of course, the question is, how do we get 10? In this video, I will show you 2 different solutions. So the first one is by using sine law, or the law of sine. And the second one is the cosine law, or the law of cosine. We have 2 different solutions and we arrive at the same answer. So let's begin with the first solution using law of sine, or sine law. So this is the law of sine, or sine law. In order to solve this, what we're going to do is we need to have the remaining angle. Now we know the sum of these 3 interior angles adds up to 180 degrees. In short, this angle right over here must be equal to 180 minus 4 times alpha. So if we add all of this angle together, we get 180 degrees. Now, using the law of sine, or the sine law, we can set up some equation like this. So we have x over sine of 3 alpha equals 3 over sine of 180 degrees minus 4 alpha equals 8 over sine of alpha. So given this result, we can now solve for the value of x. So now, let's first equate x over 3 times alpha to 8 over sine alpha. And of course, we will use some identities for this, trigonometric identities. And the first one is this sine of 3x. This is equivalent to negative 4 sine cube x plus 3 times sine of x. In short, we can rewrite sine of 3 alpha as follows: negative 4 sine cube alpha plus 3 times sine alpha. Now, cross multiply, and on the right hand side, let's factor out sine alpha. Divide both sides by sine alpha. We have x equals negative 32 sine squared alpha plus 24. If we get the value of sine squared alpha, then we're done. Now, let's set aside this result. And in order to find the value of sine squared alpha, we will use this equation, 3 over sine of 180 degrees minus 4 alpha equals 8 over sine alpha. Now, we have another identity. If we have sine of 180 degrees minus x, this is just sine of x. In short, this sine of 180 degrees minus 4 alpha, this is just sine of 4 alpha. Now, this 4 alpha, we can rewrite this as 2 times 2 alpha. In short, we can use this identity, sine of 2x. Because if we have this sine of 2x, this is equivalent to 2 times sine x times cosine x. In short, we can rewrite sine of 4 alpha into 2 times sine of 2 alpha times cosine 2 alpha. And again, we have sine 2 alpha. So we can use again this identity, sine of 2x. And if we do that, we get 4 times sine alpha cosine alpha times cosine of 2 alpha. As you can see, we can eliminate sine alpha on both sides. And now let's focus on this result. What we're going to do is to cross multiply, and cosine 2 alpha, we have again some identities for this, because cosine 2x is equal to 2 times cosine squared x minus 1. So in order to answer this kind of question, we need to review our trigonometric identities. So we can replace cosine of 2 alpha with 2 times cosine squared alpha minus 1. And now, to simplify this equation, let y be equal to cosine alpha. So this equation becomes 3 equals 32y times 2y squared minus 1. Now, combining all of these terms, simplify, and we get this cubic equation, 64y cubed minus 32y minus 3 equals to 0. Now, we can factor this using a lot of factoring techniques. We can use synthetic division or guess and check method, but at the end of the day, we get the factor of 4y minus 3 multiplied by 16y squared plus 12y plus 1. And on the first factor, we get that the value of y is 3 over 4. And the second factor, we get that y equals negative 3 plus or minus square root of 5 over 8. Now take note, this y cannot be a negative number. Otherwise, this angle alpha will go beyond the 90 to 180 degrees. But this alpha technically is an acute angle. In short, we can say that y simply equal to 3 over 4. Now, we know that y equals 3 over 4, and this y is also equal to cosine alpha. In short, we can say that cosine alpha equals 3 over 4. Now, we can now find the value of sine squared alpha using this identity, the Pythagorean identity. So, sine squared x plus cosine squared x equals 1. Now, replacing cosine alpha with 3 over 4, we have sine squared alpha plus 3 over 4 raised to the power of 2 equals 1. Simplify, we have 9 over 16. Subtract 9 over 16 on both sides. We get sine squared alpha equals 7 over 16. Now, we have the value for sine squared alpha. In short, we can now find the value of x. So, just replace sine squared alpha with 7 over 16. Simplify, we have negative 14 plus 24, and negative 14 plus 24 simply will give us x equals 10. And that is our answer to this question. So, using the law of sine, we get that the value of x, or the length of this segment, simply equal to 10 units. Now, how about the use of cosine law? This is a bit short than the sine law. So let's have the solution using the law of cosine. Now, in order to use the law of cosine, we need to add some segments in our figure. So let's cut this into alpha like this. Now, using what we call exterior angle theorem, or the remote exterior angle theorem, we can say that this angle right over here is just the sum of alpha and alpha, which is equal to 2 alpha. In short, we now have two isosceles triangle. This one on the top and this one on the bottom part. But take note, we know that the full length of this longer side is simply equal to x. Now, since this triangle on the top is an isosceles, the other side is also equal to 8. Now, if this is 8, this side length is simply equal to x minus 8. Now, since this triangle on the bottom part is an isosceles triangle, the other side is also equal to x minus 8. Now, we are now ready to use what we call the law of cosine. So, using this triangle right over here, the biggest triangle. So, using the law of cosine, we have 8 squared equals x squared plus 3 squared minus 2 times 3x times cosine of alpha. Now, if we want to solve for the cosine alpha, we get that cosine alpha equals x squared minus 55 over 6x. Just manipulate this equation. Now, using this triangle on the bottom part, and again, using the law of cosine, we get that x minus 8 raised to the power of 2 equals 3 squared plus x minus 8 raised to the power of 2 minus 2 times 3 times x minus 8 times cosine alpha. Now take note, x minus 8 squared and x minus 8 squared are gone. This is just 0. In short, if we get cosine of alpha, we get 9 over 6 times x minus 8. We have two expressions that is equivalent to cosine alpha. In short, they are just the same thing. Now, if this is just the same thing, what we're going to do is to simplify this and solve for the value of x. So first thing to do is to eliminate this 6. These 6 are gone. It's just equal to 1. Now, cross multiply. Now, simplify this expression and equate this to 0. We get x cubed minus 8x squared minus 64x plus 440 equals to 0. Now, let's focus on this result. And again, using some factoring techniques, we can factor this cubic equation into x minus 10 multiplied by x squared plus 2x minus 44 equals to 0. Now, we get that x equals 10 on the first factor, and on the second factor, we get that x equals to negative 1 plus or minus 3 times square root of 5. X cannot be a negative number for sure because this is a side length. And also, this x cannot be less than 8. This one, negative 1 plus 3 times square root of 5 is clearly less than 8. In short, the only acceptable value for x is this value of x, which is equal to 10. And that is our answer to this question. Therefore, given this figure and using two different solutions, sine law and cosine law, we get that the value of this variable x simply equal to 10 units. And as always, we are done.